Ready?
Hello, everyone.
Oh, oh, hi.
Hopefully the levels are good.
Yeah, I don't know. Because we're operating two separate stream setups, which is weird. Hi. Yeah. Oh.
Thank you for the follow, Ben 2014-002.
Oh.
Welcome to the stream.
Yeah. So today is going to be a weird joint stream thing.
It's gonna be cool. Let's be honest.
Pardon me. I initially suggested this as a joke to Rachel, but she wanted to do it. So, oh, hi Derek. Boom. So yeah. So today we're going to be working on my quote-unquote top secret project. It's not secret though. It's open source hardware PCI Express Gen 3 analyzer. Because that kind of thing doesn't actually.
Well, you absolutely have to go new.
Yeah.
Or it's like new.
Yeah.
Jeez.
Top secret means it's cooler. Well, it's not top secret anymore. I'm sharing it. But yeah. So it's a PCI Express Gen 3 analyzer with X16 capabilities. So, in theory, it can do a full-speed PCI Express X16 link, but in practice, we'll see how that goes. It's designed in such a way where it can operate as either 4x4 analyzers, 2x8 analyzers, 1x16 analyzer, or also 4x1. Or, well, I guess you could do 16x1 if you tried hard enough.
Yeah, you probably could.
It's not really designed for that, though. But yeah, so it's...
To be fair, that is really difficult to do, so, like...
Yeah.
Eh.
But yeah, so it's a fairly complicated project, and there's lots going on. It's based around two Kintex 24T, I forget the exact part number.
XC7K325T.
Yeah.
They're chunky.
Oh.
And yes, my eggers, they are indeed quite the rat's nest right at the moment.
Yeah.
Welcome, Benny from Master's Discord.
Yeah, that's
Good
not
to know
even
that is who you are.
That's not even anything. Hi, Amy. It's gonna get so much more complicated. Because we've also.
Oh yeah.
So the way it's broken up is I'm using SF8644 mini SAS HD connectors because those are designed to have NVMe traffic for them. And what is NVMe but boneless PCI Express? So,
pretty much.
Excuse me. So that's.
I hope I'm soldering this by hand.
Yeah.
No, actually, we're gonna try and get the board house to fabricate.
Yeah, this is going to have to be assembled by the board house. This thing is going to be expensive. So it's a 8-layer HDI 3mm trace space board.
This is the stack up here.
Yeah.
This thing is just kind of nuts.
Yeah. NVMe is just.
NVMe is it's essentially PCIe.
Yeah.
Ish.
Yeah. So what's going on is because the really chunky FPGAs to handle 1x16 stream are too expensive. The slightly less expensive at only 1.2 grand per FPGA are the next step down, but that has half the transceivers. Yeah, thick piece. Like
it's only 1.6 millimeter thick.
Yeah.
NVMe is a modified version of PCIe. It's not strictly speaking purely standards conformant PCIe, but the signaling is PCIe.
Yeah,
as far as we're concerned.
It's the same signaling. So, but yeah, but you can actually get these really chunky AF FPGAs off LCSC for literally 1/10 the price you can anywhere else. which kind
These
of
are nuts.
makes this more reasonable. So it's split down the middle. So we have 4 links, A, B, C, and D. Each link represents an X4 pair, or an X4 connection, basically. So it's split down the middle between 8x being handled by 1 CPU or 1 FPGA.
FPGA. Sorry, continue.
I don't think that's a bug, but yeah. Yeah, Kintex 7. 8x handled by the other one, and then they have to cooperate for the full X16 link mode, which is going to be kind of a pain in the butt. But we have plans for that. Each FPGA has 8 gigs of cache.
DDR3L.
Yep, 8 gigs of DDR3L per FPGA for caching the data. It's then going to be moved over to, it's not on the board yet, but I'm still making the part, but it's going to be moved over to a Zinc, which will be running the firmware and the glue logic to glue these two together into a USB 3 PHY, which will then be able to spit out, hopefully at 5 gigabits a second, a decent analysis stream. The issue is all the filtering and triggering has to be done in the FPGAs themselves, just because the band, it's unrealistic for us to pipe that much data over USB 3.
To answer Jiggly Girls, by the way, welcome to my stream and thanks for joining us. Yeah, these are Kintex 7s. These are chonky Kintex 7s.
Yeah, I actually have a picture of the Kintex 7s. So these are the actual Kintex 7s that this board is designed for. Ignore the scribbles.
I should, could you give me a link to that real quick and then I can show my stream too?
Yeah, I can give you a link to that. So, yeah, the left Kintex 7 and the right Kintex 7 are these two. Right here.
Also, Aki did a really cute thing. These are adorable. Yeah.
There's
nice.
The chat is split between my stream and Rachel's stream.
Yeah, we're dual streaming.
Yeah, I have both chat windows open. Nanometers. It's sad. All the nanometers.
It's that's a good question. What process node is this using?
26 nanometer.
That would make a lot of sense, actually.
I can actually answer that in a second once Xilinx website decides to.
I'm currently looking at the product page and.
Yeah.
It doesn't list it anywhere obvious, but I would think it's probably about 28 nano.
Oh yeah, 28 nanometers. The ultra scale stuff's 20 nanometers, and the ultra scale plus stuff's 16 nanometers. Yeah, thanks. Yeah. All the cute FPGA stuff.
That is very cute.
But yeah, so I'm going to be working on getting the management SOC and the the USB host interface sorted. Rachel is going to do power supply stuff, I believe.
Yeah, I'm going to be working on switch mode power supplies, because holy rails!
Yeah, so this thing wants 5 volt, 3.3 volt, 1.8 volt, 1.5 volt, 1.2 volt, 1.1 volt, 1 volt, and I think we need 1.3 volt for the DDR3L.
Well, I'm going to figure out the DDR part in a bit.
Well, I'm
yeah,
pretty sure the DDR3 the DDR3 stuff can run off of 1.5
So it depends
volts.
on what speed we want to run it at, and under what JEDEC conditions, and no.
Well, yeah.
Yes, they do, Steffi, and that's actually part of the thing that we're going to be doing. I'm going to be going and finding probably the analog devices, because that tends to be who Xilinx pairs with, and I'm going to try and find the right analog devices part, throw it on, but also we've got to guarantee not just the Kintex 7s, but also a Zinc.
Yeah. To Kintex 7...
Which is it's a Kintex 7 wearing some strange clothing.
Oh, it's an Arctic 7 with an ARM core bolted on it. A hat.
Is it Artex?
Yeah,
Okay,
the higher
well,
end
anyway.
Zincs are Kintex. Oh! Thank you for following Gaboros. And yeah, this is all gonna
yes,
be...
Ben, code will be written open source.
Yeah. Oh, Trickly Girls is now following. Yeah, so the entire project is open source. That's the documentation, hardware, as much as I can make it, which is basically everything but the discrete ICs.
There are 2 Kintex 7s and a Zinc. Yes, Steffi.
Yeah.
There are 3 FPGAs for this.
Well, there's always going to be 3 FPGAs. Because I have to glue...
I think we just broke Steffi.
I need a third FPGA to glue the other 2 FPGAs together. But yeah.
And also be able to, you know, amalgamate the giant pipe of data in any kind of meaningful way.
Yeah. But yeah, all the software is going to be open source, all the hardware, all the documentation. The analyzer aspect is going to be rolled into Nox, which is another project of mine, which is PCI Express analysis client software for the Agilent stuff.
Sorry. Freya's comment's brilliant. Yes.
It's a polycode of FPGAs. But yeah, so the analysis stuff will be done in Nox, but the actual hardware and stuff is going to be a standalone project. I'm going to also potentially add an RTC because we want to do accurate timestamping of packets, and that, like, it's going to have a status mezzanine, which runs a Tiva C. It's got, 2 Kintexes, a Zinc, 9 DDR3 chips, a TUSB 1310A, USB 3.5.
Yes, Steffi. Yes.
Yeah. And we're using KiCad Nightly for the fancy bus definitions, and as you can see, I am abusing buses quite heavily.
Oh yeah, the buses on this thing are nuts. No, I don't want the navigator. I wanted to go up a page.
Yeah. But yeah.
There we go. Have some buses.
And the project name, Yumekui. How do you get...
This is a theme. I actually built an eagle theme for KiCad Nightly, which you can find... where can you find that right now?
Yeah, and then I have my own theme I wrote for KiCad. But yeah, so...
Here we go. KiCad color schemes. There is an eagle theme in here, which is the one I built. Have a link in chat. And that's what you see me using.
Yep.
It's dark by default. I haven't done a light mode version yet. Yeah. And it tries to be polite and kind to people who have color blindness. I don't know how well I've succeeded, because that's a really difficult one.
Yeah.
But I know it's better than the default theme, so...
Yeah. But, yeah, so... The name, Yumekui, basically means Dream Eater. And I chose that because...
I mean, you could just leave it as because.
Just because, yeah, no, but because I don't actually have a hope in the world of manufacturing and assembling this board.
It is Steffi.
It's where the dream goes to die, right?
There's a link for Aki's chat. I mean, you say you don't have a hope in hell, but actually I think you've got a very good chance, because you've been designing this for manufacture pretty darn well.
I mean, I've been trying.
Yep.
The issue is it's going to be expensive. So for at the current PCB size, for 5 boards, it's going to be about $1,000. That's not including parts, that's not including assembly. The parts themselves are going to cost a lot. The passives are basically, for all intents and purposes, can be considered free, but the big chips, the 2 FPGAs, that's $300 for those two FPGAs if we get them from LCSC, plus the zinc, so that's another $50 plus the.
It's a
Alright,
lot.
it's a lot.
We add up quickly.
It's probably almost another grand in parts.
So to answer Ben, the buttons etc. are actually the KiCad default ones in Nightly. They drastically improved the buttons. Complete redesign so it would work with both dark and light theming.
Yep.
And then my theme is Materia Dark.
Yeah. Oh, yeah, I am not...
That's my desktop environment theme.
This board would not fit in my toaster oven. I could not flow this at home. And yeah, then the assembly cost, right? It's going to be another grand on top of that.
Yeah.
And then we have the case, and I think I picked out a nice case. I wanted it in.
Oh yeah, you picked out a lovely case. I like the case. This Thor Labs thing.
Yeah.
Is
good. This is the case I want to go with. It's and they can do cutouts and stuff. So it'll fit there. The front panel stuff will go there. There'll be a status mezzanine. It's going to have just because. Soon, I will make a huge vapor phase soon. It's going to have a status mezzanine, which is going to have an OLED display on it, as well as RGB status indicators.
Just do it.
I could just do what Reps did and get a hotel pan and a hot plate.
Hey, it works.
Yeah, but I'm not too keen on the potential risk of, hydrofluoric acid. So, Reps is braver than I am.
Well, I'm gonna get designing.
Yeah. So
Let's see, we want to do DC-DC power management. Aha. Or at least that should be where it is.
Yeah, so what I'm doing is I'm making the symbol and the footprint for the USB 1310A, which is the... Yes, because I'm leveraging sub-schematics very, very hard to a large extent.
Yeah, I'm able to work just inside the power subsheet while Aki's working on like the USB subsheet and...
Yeah. Hopefully we won't have too many merge conflicts.
Hopefully we won't have any, because hopefully I do my job right.
But yeah, so fun thing with, or quote-unquote fun thing, with this godforsaken chip, TUSB 1310, I didn't want to do that, but yeah, so it's not recommended for designs, and it's the only physical discrete USB 3 PHY you can get. It's the only one. They don't make any of them. They make like USB 3 hubs and power PD stuff, but you can't get like discrete PHYs except this one. It's not recommended for new designs, and I don't know how long it will stick around, which is kind of terrifying. I don't like relying on that. Yeah, you're expected to buy IP and roll it into an ASIC or have an FPGA or something like that. Yeah. And the other option was using a SI USB 3014, but that runs another... That's basically a microcontroller with a USB 3 PHY built in and GPIP2. And I didn't want another bit of code to have to write for this, because I'm going to have to write gateware for the upper link FPGA, gateware for the lower link FPGA, gateware for the zinc, firmware for the zinc, firmware for the status mezzanine controller, as well as the client-side control application. So that's already 6 independent bits of software and gateware and firmware.
Yeah, Easy USB 3 is indeed an entire microcontroller. It's an ARM-based thing.
Yeah, that's what the Easy USB 3 is, the CY USB 3014. But yeah, so...
Oh hey, apparently the ADP 5050 is the exact thing I need to power the...
Hey, I already have that in my library, so you can just use that.
Yeah. Although that's showing a Spartan 6.
ADP 50.
But is this?
No, it couldn't replace the whole third FPGA. Not enough I/O, and it needs to be It needs to be a Zinc.
Or at least something that is chunky enough to be able to handle that quantity of data.
Yeah, well, because I have to glue. I'm taking high-speed differential, 2-lane high-speed differential from each FPGA symbol transposition over to the management sock.
Packaging it all up and throwing it using isochronous mode USB over onto the host.
Yeah. It's a whole thing. And also the micros programming the FPGAs. I don't want to have multiple flashes on this board, so the Zinc is also handling the FPGA configuration, and to get the timings good for that, that needs to be programmable logic. So a Zinc is like the perfect device.
Yeah.
It has a gigabit Ethernet PHY. It has USB 2 PHY, but they're too slow. I could use XGMI, but I'll run out.
And moreover, with gigabit Ethernet, even if it was fast enough, you have the problem that if there is any kind of congestion on the network, etc., you're done. That's it.
Oh, it would be point to point.
Yeah.
I mean, it would have to be.
So it looks like the ADP 5050 is available for powering the Kintex 7 series. So,
yeah,
that's good.
Okay.
Yeah, okay. Let's go and look for an ADP 5050 on Farnell.
I mean, I use the ADP 5050 ACPZ R7. I've used that for previous designs.
That's the exact one that came up.
And that's already in my library. So.
Oh, excellent. Whee!
So yeah.
I still need the datasheet up, so there is that.
Oh yeah. So.
Oh, and if anyone's wondering, by the way, how my datasheets, etc., are all coming up instantly dark mode, I have an extension on my browser. This is Dark Reader, and it's inverting everything for me and applying some nice, like, making it so my ice don't burn and bleed.
This will need.
Because that's a thing.
One.
I'm probably going to need a couple.
Yeah, well, the thing is, so these Kintex are going to pull a lot of current. They're going to...
Yeah.
That, and each ADP 5050 only gives you 4 independent rails. We need... How many rails?
5, actually. Because the LDO is apparently suitable for driving the transceivers. So the front-end transceivers for PCIe I can do using the LDO.
Alright, 5, but we still have like almost 10 independent 10 voltages we need. So we'll only need at least 2.
Yep.
That, and we need to pull a
okay.
whack ton of current. So this board is going to be using 2 EPS 12-volt connectors.
Gonna be good.
And it's standard motherboard pinout, so you could probably, I don't know, get a server power supply to run this board off of. Yeah, they're gonna need heat sinks. I think this might need active cooling. Maybe. I want to say around 300. Like at peak, everything's newing as fast as it can.
Yeah, I would expect something like that too.
Yeah.
New.
4 and I need
Cute.
1, 2,
Right.
3. Yeah, 4 sounds good.
She's the cute one.
Meow. Meow. Meow.
Yeah, you are.
Okay. So let's go with. So for those who don't know, the pipe interface is an abomination invented by Intel.
Aw, fine. I guess I have to accept that. I hope everyone's doing okay in my chat and on my stream. If I'm not boring you, because I have been kind of static screening while Aki's done some explainer on the project.
I mean, so have I. I've been sitting here just moving my mouse around.
Yeah, but at least they got to see what you were explaining. Right. We need data sheets a bit extra.
So TC.
Like, at least I get a nice block diagram of everything inside the ADP 5050. So there is that.
Okay, turn that to input. Directional input. This one is TX data 15 pin number G2.
I know you've already got the pin out for this, right? So there is that.
Of course I got the pin out.
I'm just commenting, it means it's one less thing I have to worry about.
Yeah. G2. So this is just gonna be a busy work stream, basically. Next
Well, at least the ADP 5050 having PSM mode means that for rails that are low usage or when the device is mostly idle, we won't be burning tons of power trying to do the 12 to voltage conversion.
That's good. 12 is J2. So yeah, the pipe interface has like a bazillion pins and is just awful. I hate it. I hate it so much.
Yeah.
11 L3.
No, not more pin, less pin. Already too many.
As it stands, I might need to get a bigger
Zinc.
the zinc just so we have a larger package. I don't think that the 280 pin zincs are gonna be enough.
Yeah.
Which is
terrifying to get to say. It's like, what are we even doing at that point?
Yeah. So this project is a result of me being haunted by a dream to make a PCI Express analyzer for a literal month. So
pets. Because it's a good dream. It's a really good thing that we're doing, because there are no open source or even cost-effective analyzers out there at the moment.
Well, yeah, you can't even... Well,
eye-wateringly expensive.
You can't get the standards, which is one of the problems. Well, okay, you can get the standards. I have the standards. I didn't pay for the standards. It took effort. I don't condone piracy. But...
the whole thing?
The PCI Express is not... You're allowed to condone piracy. I am not allowed to condone piracy. So...
I'm neither allowed to condone or not allowed to condone piracy. It's things, stuff. I have to be careful what I say. I hate my job.
Renting standard disk images. Yeah, really. Honestly, some of these FPGAs cost more than a house. So yeah, that would be right up Mr. Beast's alley. Which...
I am so glad that the friggin' bug to do with wires got fixed, cause...
did it?
Yeah! Did you not notice that you can now click and start,
No, I still run into it.
Oh yeah, Mr. Beast giving FPGAs away, that would be great. It's in the version that you're running.
No, yeah,
that bug was fixed in...
I still run into that problem.
What, where you can start a wire and it doesn't start where you placed it?
Yeah.
Oh, okay. Huh.
Sorry, this is kind of boring. I'm just making a part. So it's perfect time for chatting.
Mm-hmm. I'm starting to redefine how on earth the ADP 5050 works.
Oh, Rachel, I have some to-do lists in the root of the repo.
Mm-hmm.
So take a look at those, and if you do a thing,
Yep, we will do so in a bit.
check the thing.
Yar.
Check yourself before you wreck yourself, as they say. As the kids say. Gosh darn
Indeed.
damn whippersnappers, always doing the YOLOs and the OMGs.
Now, do I want an L small, L iron small, L ferrite small? I think I want L ferrite small because they're going to be ferrite core inductors. That's the most reasonable symbol for what I'm doing.
Okie dokie. O2.
Coilcraft good with you?
Yeah, they're the only ones that we've been able to reliably source the needed inductors from, so.
Ah, yeah, there is that. I figured I'd ask though before I just be like, okay, we're using these inductors. Yeah, like, I can't get those.
Yeah, well,
Because that would suck.
assuming I get the board, I'm gonna have to, if I get the boards done, we're gonna have to get all the parts so I can put a package together to send
Mm-hmm.
To the board house. Or, so this is a thought, and
Yeah, they are the good ones.
I think Esden still, because it's like, it's early over there. But I was gonna ask Esden if maybe he wanted to try and do a run of these boards in exchange for being able to keep one.
Yeah. I think he'd probably jump with that. Honestly, I think he'd go with that.
And
because-
payment, of course. I wouldn't just say, yeah, you get to keep a
Yes.
board. I'd be like, yeah, and I don't know. I'll figure out how to pay you.
Yeah.
Yeah, that okay. Oops, that's not what I wanted.
He lives in Oregon.
West Coast. Yeah.
Yeah.
This is G1. And he has a pick and place machine, something I do not have.
Yes, he does.
Although I don't know if it will
Uh.
fit in his reflow oven.
It'll be fine.
8 layers and a lot of copper.
Mm-hmm.
Oops, everything shorted the ground. God, please no. Diagnosing, debugging, and reworking this board is going to be an absolute fucking
Nightmare?
nightmare, yeah.
Yeah.
Oof. Yeah, I'm not a fan of QT in general, so. Yeah, dedicate one. That is not correct. Actually, get your shit together.
Okay.
That is J1.
I need to figure out exactly what rails I need. I've just been throwing components in because I know I need those particular components.
Yeah.
We're not going to gang the two channels, 1 and 2 together. We're going to do 2 separate channels there. But, like...
You think they could push enough current?
They're 4 amp each. Which if we're putting... They're designed to be able to handle a single FPGA each.
Okay. So are we gonna have 3, 1 per FPGA, or are we gonna have...
We could. It would be a lot of board space, though. I was thinking, because you've got 4 amp, 4 amp, 1.2 amp, 1.2 amp, 200 milliamp per. We'll do like the core, the VCC in, VCC aux, and VCC BRAM, those kind of things will be handled by a buck 1, buck 3 pair on each ADP 50/50 for the 2 Kintexes. That leaves me a buck 2, which is another 4 amp buck, to be able to do the core rails for the zinc. And then we've got 1.2 amp buck 4 for the gigabit transceivers, or actually no, they're not gigabit, they're actually quite a bit more than gigabit. The transceivers that are doing the PCIe.
What is the
And then like the ref and termination stuff is done through the LDO.
What is the... So were you...
And that leaves me with a small number of rails extra that we have to source another part for. And I think I can do it in 2 ADP 50/50s plus a little extra then.
Okay. Well, can you check all the parts to make sure we have all the voltage rails we need first?
I am going to do that, yes. That's actually the next step. Is I'm going to start by making sure I've got the right voltage rails for the Kintex 7.
Yeah. So the Kintex 7 has the GTX transceivers, which are 12.5 gigabit a second, which has a maximum peak bandwidth of the high-end Kintex of 800 gigabits per second.
Which is just... Oh,
we're about
I
half,
want one.
I think we're about half that because we have half the transceivers. And we're only using the RX lines. Our TX lines are completely unconnected, which feels like such a waste of these FPGAs.
It's what it is.
So, oh, also, I should explain this a little bit. So, I slightly augmented the pinout. Hi, Addie.
Hey, Auntie.
It's a PCI Express Gen 3 analyzer. Fully open source hardware.
But also, have you seen how fast PCIe by 1 goes? Oh yeah,
PCIe
it's
X1
extra.
Gen 3 goes 8 gigabit a second, which is why I needed the Kintex, because each transceiver needed to be able to reach that.
Yep.
And
terrifyingly fast.
I could have done it with a really high-end Zinc, kind of, but not really. And the reason I need 2 is because the 2 Kintexes each have 16 channels, so that's 32 channels, because each needs to monitor uplink and downlink at the same time. And for that reason, we're using all the transceiver receives, but we're not using any of the transceiver transmits.
Yep.
Yeah.
So this is a -2 speed grade part. Specifically, it's the industrial -2. But that means it is not a -2 LE or IL, so I don't have to do anything special with the core rails, which are VCC int and BRAM. Those get to be set to 1 volt, and aux is 1.8. That's...
Yeah, Eddie. Yeah, it's a fully open source hardware, software, gateware. It's all open source PCI Express Gen 3 analyzer. Because the market's missing this because you can only get them from places like Teledyne LaCroix or Keysight or
just crying money at that point.
Electronics for like as much as a new car costs. And I understand why. This is a hard problem to solve. The downside is a lot of those are PCI Express analyzers and jammers. This is just going to be an analyzer due to the complexity. But yeah, I want it to be fully open source. I maybe want to sell them.
Yeah, scary prices indeed.
Right? If we could get like a crowdsourced campaign going to help cover some of the manufacturing costs. Full 16 bits. Full by 16. So
I'm gonna move the power send section around very slightly, dear, as I need to add a couple more 1 volt rails.
That's
Because this thing's just extra. I'm gonna need to have a 1 volt for the left hand Kintex and a 1 volt for the right hand Kintex to drive enough current for each.
You shouldn't need to move any of that. We can just make the traces really fat.
No, what I mean is that so I don't have the two 1 volt outputs connected to each other on the board. I need them to be unique wires in the schematic.
That's gonna be annoying. Okay, fine.
I know. But it's fine. I'm gonna label it so you know which one's which.
Okay. Don't import the sheets up hierarchical.
I won't.
Or the pins up. We'll do that. I'll do that in merge. Yeah. So
Yep.
it's full by 16, but due to its architecture, it can operate in 2x8, or 4x4, or 4x1, and it has triggering for sideband. So the extra connectors on the PCI Express, like the S bus and the JTAG and the ref block and all that stuff, are broken out over mini DisplayPort, and those also plug into this. So per link, you can trigger on any of the sideband connections, and I also want to add a general GPIO trigger block, and that will be per link. The issue is, because we're running two independent FPGAs, the by 16 shared mode is especially difficult. Synchronize. Mainly, we just have to synchronize the triggers between the FPGAs. Because the data is all going to be in parallel anyway. Yeah. Yeah, the syncing the triggers and the ref clock is going to be a challenge.
The spicy part.
Then
It'll be a spicier meatball.
each FPGA has the 8 gigs of cache. In reality, it's only 4. So it writes to fill up one, which we then drain, and then it writes to fill up another, which we then drain. So we're only writing to one half of the DDR3 cache at once. And then the management sock has its own little cache. USB 3.
Yeah.
Unless we're doing like a direct connect InfiniBand or XGMII 10 gig 100 gig Ethernet, we're not going to have enough bandwidth to stream a pure PCI Express connection. So all of the triggering and filtering have to be done in hardware. So we have to build like I was thinking of basing it off binary packet filter and just writing some gateway to interpret that stuff, which you can then load onto the FPGAs to do the filtering. Or the Berkeley
For those
packet.
wondering, by the way, how I'm able to like duplicate labels so quickly and easily and nightly, I did some key remapping. Because nightly changed some stuff. If we go into the hotkeys, C is now bound to unfold from bus instead of being clone, which is actually renamed duplicate, which I have now bound to D. It is normally Control C. Because
Yeah, that's fatty. The idea behind it is that we can do. It gives us a little more of a buffer, and because dual port SDRAM is expensive, we have to do this whole double buffer thing.
it's a whole thing.
So yeah.
Enjoy while we go quietly crazy.
Yeah, I eventually might want to do a crowdsource campaign on this if people would be if enough people would be interested in it. So each FPGA takes half the TX signals and half the RX signals from a PCI. So for a 4-link, it takes both the upstream and downstream. So we're capturing both upstream and downstream, which is why we needed double the amount of transceivers as we have lanes. If that makes any sense. So we're able to capture both sides of the bus simultaneously. And again, we're not using any of the transmit. We're only using all of the receive, and it feels like a waste.
It's not, though.
That's the RX data. Well, it would be 8. No. That would create too much crossover. That would make routing an absolute nightmare. So
that's putting it
the
politely.
uplink and downlink are both sent to, for each lane are sent to an FPGA. This helps us correlate data better too, right? So each packet we can generate knows an uplink, knows downlink for its particular set of lanes. The first 8 for FPGA 1, the last 8 for FPGA 2. And it just makes routing in general easier that way. I have no idea if this architecture will work. This is based completely on a guess. I'm just flying by the seat of my pants here. So...
it's all good.
We'll see.
You make good guesses, and they're usually correct. So, you know... no other way to fly. Agreed.
Yeah, I don't do much with, I don't know enough about PCI in general to be doing this, but here I am, doing it anyway. I mean,
PCI is spooky.
Yeah. Granted, I have the standards, but that's only because I was a stubborn bitch and went and found them because just to spite PCI SIG. Yeah, I liked to joke a while ago, the best way for me to learn how to do something is to tie cinder blocks to my feet and then jump in the deep end of the pool. Which is not a great analogy, now that I think about it. But...
It kind of is how you do it, though, but also...
It's not a great analogy, but it describes pretty accurately how I do things. I just like this song.
Let me move that.
90984. I feel bad for people that look up to me saying, "Oh, you're so experienced, you're good at this." No, I'm not. I just mindlessly flail around and manage to accidentally do things.
It's a lot more on purpose than by accident, dear.
It feels like it's purely an accident.
Well, I can vouch that you manage to do things because you're actually really good.
I don't believe that.
I know you don't. That's okay, because I believe in it for you.
RX, it was 6.
Yeah, exactly, Freya.
Maybe. Yeah. I am still so mad. Texas Instruments is... there's only one USB 3 PHY, and it's annoying. Yeah, well, Addy, that's where I run into a lot of problems too. I will hit a roadblock that I absolutely don't know how to do, and just kind of, I don't know, freak out or make bad guesses.
Have a slight brain shutdown. I think it's a slightly politer way to put it.
But I get that. 605. You're using 0402 components, right there?
I haven't yet set any footprints. I'm currently just building a schematic for what I know is required to make this thing work. But I can use 0402, yes.
What was I doing? B1? Was it B1? It was B1. RX 04 C2. You sunk my battleship.
Ah, that's good.
I know it's not a unique problem, which is why I feel bad for complaining about it. And talking about it.
There's nothing to feel bad about there. Oh, take care, Auntie.
Oh, okay, bye, Eddie. Oh gosh, you're gonna VOD this, aren't you, Rachel? Yeah.
Yeah.
No VOD, bad.
Yeah, no, VOD, good.
Not bad.
No, because it means that people actually get to see what you managed to do. And it's really cool. Or at least here in this case, because I haven't actually got your stream on displaying on mine. Sorry, but...
I prefer to be ephemeral, though.
Bye, Auntie. Take care.
Bye, Addie. Data 2 is B1.
Agreed, Steffi. Oh, this is gonna be a pain. I need to find a particular kind of NFET. I need a dual FET in a package, because they have to be bonded for the two high current channels to work properly. They're mandatory.
There was a Vishay FET I used on Lethal Link. What part was that?
This needs to be a pair of N MOSFETs.
Let me scheme up. File, open, project. Hardware board.
Is this the FET?
I was
Is there a
using
generic one?
this.
Okay.
I don't know if it'll fit. But that's
Let's
what I
see what this is and if it works for the application. Dual 20 volt DS MOSFET. Ooh. 20 amp drain source current.
Oh yeah, he's chonky.
Oh, that's a lot of current. Okay.
There was a
And
reason I
that's
was
in
using
library,
it. It
is
was entirely overkill.
Oh, that's fine. Overkill's good in this case.
No kill quite like overkill.
Yeah, really. I love how, like, the drain is this giant massive pad, and the source is this one little tiny pad. And it's like,
Yeah,
but the source has to be able to handle 20 amps too? What?
That might be already in my library.
Excellent.
You can check.
Oh, go on, have a look in a moment.
RX valid in F1.
Oh, I should make sure that this can take 12 volts in. It should be able to. Yeah, wide input voltage range. 4.5 volts to 15 volts.
Okay, yes, we're at the... Which isn't bad.
Yeah. This is like right in the sweet spot for this chip.
Yeah. Oh gosh, I assume all of you have seen my thread about cat faces on FPGA, right? I just have to ask though, because maybe someone hasn't seen it.
Ah, the ADP 5052 dispenses with the I2C. That's why I was using ADP 5052. Ooh.
Yeah. I don't care either way.
£9.55 versus £7.81. Do you want me to go for the cheaper part?
At this point, I don't care. We're only going to be using 2 of them. We can do cost off. We'll design it first, and then we can do cost optimization after.
Okay. The basic theory of operation for the 2 is the same, so that's fine.
Yeah. This is an input. TX. What on earth is the name? TX, det, RX, LP, BK. TI, get your shit together.
Yeah.
TX, elec, idle.
I guess actually if we did leave the I2C on here, then... Oh, actually no, because then...
They'll have
like,
the same
oh,
cost.
no, it's not that. It's the... If we had like an overcurrent event or something and something went wrong, then we could let the zinc know and report it. Oh, right, the zinc can't, because that'll be down too.
Well, actually, we could run that over the mezzanine connector, and then the mezzanine would probably...
Yeah, that's true. It could go into... Yeah, that's a good way of doing it.
Well, the mezzanine would be running off the 5-volt rail. Which
we could put 12 volts down the mezzanine connector, and then we can put a small power supply on the target board.
Yeah, we could do that, too. That would be an option.
And that way we've got the ability for the front panel to report of, like, over voltage, over current conditions, etc.
Yeah.
Without going down. I think that's actually a bit of smart design, because that way we've got some safeties in there, which is good, because we're talking some pretty high current.
Yeah.
So, why is it burning? Oh shit, it's over current. Boom. Oops.
Yeah, well, I think what we could do in that case is we would have to run maybe an ITC line or something over to the power supply board too, so that way the management control or the this is a lot of responsibility to be putting on the mezzanine status micro.
It's fine.
But if it detects overcurrent, it could cut power to the entire system. It's an option.
Cut power to itself at that point.
Yeah, but at least it would be like it would save itself.
True. If it went over current though, what this could do, if it's got the I2C lines, is it can talk to these controllers and just turn them off.
Yeah.
Which also saves us in a nice way.
Yeah, it could turn them off and then go panic mode on the status display.
Mm-hmm.
Elect idle is F3.
Because yeah, the I2C bus on this thing does contain enables, so we can just say, no, you're done now. Your outputs are all disabled, which is nice.
Status 1, C6.
Talking of catcalls on oscilloscopes, I really need to take a nice picture of my scope now. Thank you, dear. Cause it's cute. It's really, really cute.
You gotta have custom oscilloscope firmware for your fiance.
Oh yeah. Customizing your oscilloscope? Always. Hey, Nanotech. Welcome, welcome.
Hi, Nano. I'm streaming too. Wow. Power down 0. Gosh,
So-
the fucking pipe is just too wide. This pipe is too wide.
Yeah.
Status.
We need to do a resistive voltage divider to limit the degradation of the output voltage. Ensure that the bottom resistor is not too large, no more than 50k ohm.
I still think I have the notes for the last time we did power supply design for this.
I think we probably do still have those notes, yes. How do you mean, Freya? Are we talking about my scope?
Yeah?
It's on your chat.
Yeah, I know. Yeah?
Oh, no, the pipe is 16-bit wide. It's nuts. Oh, it needs a
literally add
250 megahertz clock. It's
Yeah.
like... Oh. That's a lot of data. Very, very fast.
Yeah,
Channel 1 VREF is 0.8 volts.
Yeah, this has a lot of connector. It's 16-bit
Mhm.
and RX plus control signals. It's just a lot. It's wide. A lot of things.
Yep.
Gonna get good use out of Esden's bus link matching.
Yes. V out for this first channel is 1 volt. Divide by the VREF. Divide that by 1. Oh, hang on. That's a really annoying formula. I have to rearrange the formula.
That's just how it be.
Yeah.
Yeah, the the electrical standard itself is called pipe. So.
Do you know which of your libraries the MOSFET was in?
That should just be my standard library.
Okay.
What was it? What was the part number for that?
SI7232. Apparently.
Oh, what I think I did is I used a generic part and then I have the footprint made.
Hmm. What's the generic part?
You're gonna ask me to open the scheme library.
Sorry.
Oh, no?
Device Q, Joule, and MOS. Yeah, okay. Okay.
Oops, that was not what I wanted to close. But I closed it anyway.
Oops.
Pin name, PX margin 2, M11. Import. PX margin 1, M10.
Source on 1, gate on 1, drain on 2. Oh, looks like it's the one.
Well,
I
you
have
spoke
better
to us.
us.
Oh, no. Yeah. Swing. RX. Polarity. RX polarity.
What's
RX
the input voltages?
polarity.
Oof. I'm sorry to hear that, Hexgen.
Oh, that's pets.
Mm-hmm.
Tells Defy control presence of receiver terminations. I guess Defy does termination for us.
Yes. I hope so, because then it makes life simpler for us. A lot simpler.
Looks like it does. Yay!
Whee! Oh, right, yeah, because we've got the census coming up this weekend, haven't we? This next weekend. Or something like that. 21st. Oh, okay. Couple of weekends' time.
The last upload.
Ah. Okay.
Hey, that was the entire pipe interface.
Nice.
Now I get to make it pretty.
It's a lot of pins. Holy crap. I am reading both chats, my Aegis. As best as I can. I kind of have had myself parked on Aki's chat, I have to admit. But I do care about you as well.
Yeah.
Hmm.
Well, I mean, we could possibly do that if she shares me the link to her chat page, and I share her the link to my chat page. We could add both
technically
chats.
we could do that. Oh no, then you'll know my secret to be able to get at my stuff. Oh.
Oh no. Oh no.
It's so funny how they are about this. Streamlabs is a bit nuts about the fact that, oh, don't share that with anyone. It's like, she's my wife. I trust her. It's fine.
You should, but cool, thanks.
I really should. I really, really should trust you. Don't worry. It's fine.
TCK clock. Oh, that should be TX clock.
Oh, that would be cool, Freya. That would be really cool. Sunday, right?
Yeah, someday.
Oh, that's a terrible joke, and I love it. Yep. It's good though, right?
Bad.
In a
no.
terrible
bad.
kind of way. Right, so V out 1 volt, VREF 0.8 volts. What does that even get us? That gets us 1.25 the ratio, so I need to get 1/4.
I get this.
So if I do 0.8 volts by 1 plus 10k over 40k.
Mm-hmm.
1 volt.
Volt.
Oh, I know that 1.25 is 5/4, yes, but I'm dealing with the fact that there's a +1 in the ratio.
Ah.
So I get to remove 4/4 from that.
Gosh, you and your you people and your maths, I don't understand. My brain doesn't do math. Only
It's okay.
yeah and crash.
Aww. Yumekui. Oh. Now I want to give her hugs and pet her.
Yeah, I have a Streamlabs command. If you do !nya.
I love that way of putting it, Freya. Yes.
Yeah, it's rate limited. I had the foresight to set that up.
It's good. Okay, so 10k on the top and 40k on the bottom.
Yeah. My status was My status was IO.
And using this amazing transistor.
The chonky boy.
Yeah. It's hot.
I was happy when I found that transistor.
Good. I mean, you are a transistor, after all. Sorry, that's not horrible.
Yeah.
I'll show myself the door for that one.
Dear. Bad.
Chat enjoyed that, right?
Yeah. It was still bad. All of you get bonked. Everyone gets bonked.
Yeah, that was very much a dare I hate you, but I love you.
RX, select idle. Why is that one bidirectional?
That's great.
Universal blocking. But it is pretty good. Aw. Sorry, Steffi.
Oh.
Do I want to space it out?
The Tom Scott Van Helmer. Oh, jeez. We're not that bad. Not that bad.
You're that bad. Sorry,
mean.
that was mean. RX polarity. Oh.
Yeah, I thought so. It's DL1 and 2, which where did you put DL1 and 2, dear?
What do you mean?
All the way over there. Ah.
What do you mean? Where did I put the what? I can't see what you say.
I'm gonna have to edit your ADP 50/50 part, please.
Why?
Because you put the DLs that I need to drive the transistor way over the other side of the thing.
They work for... That part has worked for me.
That's gonna suck.
Oh yeah, I didn't say it was gonna be fun.
No, I'm editing it, sorry. That one's horrible.
Well, I'm currently editing my library and I don't want to cause a conflict.
Oh, that won't cause a merge conflict. I will make sure I do the merging politely.
Well, just in general. I don't know if it's going to cause...
Oh, right, because yeah, okay, I see. Aww.
Tell you what, copy it to the project-specific library.
Okay. Oh yeah, okay. Doop-a-doop. Just wait for it to load the editor.
Because I'm going to do that with the Kintex part anyway and make its footprint better because, Jesus, it's chunk.
What is the project-specific library? Where is it? Oh, it's all the way down there. Excellent. Save as Yumekui. Yeah.
Dreamer.
Okay.
What?
The compensation pin can stay down there. And let's move DL1 in.
Something called compensation pin. Something.
Lewd.
Maybe.
I have such a lewd wife.
I'm not lewd. I don't know what you're talking about.
You not lewd? That's funny. I'm sorry.
I am innocent. USB 3.0.
Right. Innocent.
We forbid. No. There it is.
I'm not sure it's 80%. Okay.
Innocence is relative. And
I would agree with Freya.
90%.
Hey! Less than 90%. Less than 80%. Like, maybe 3/4 at most.
I am partially responsible for that kind of stuff because I have a direct brain-to-mouth pipeline that doesn't know how to fucking shut up.
You're fine.
So, it just be like that.
Yep. And it's okay.
Oh, so I'll tell chat, but I won't mention this in the documentation for the project because I want it to be a surprise to people if I ever do sell this. So it's going to have an RTC on board, which will sync up with the host system to ensure accurate time. And because we have RGB LEDs, that means I'm going to have the analyzer display pride flags on its status LEDs during boot up during those months, because it will know what time it is and what day it is.
I approve wholeheartedly.
I keep that a secret. So you all just got secret info.
Mm-hmm.
It's not going to be mentioned in the documentation. I'm going to try and keep it obscure in the code. It is a PCIe Express Gen 3 16 lane, both upstream and downstream analyzer. It's to be completely open source from its hardware and software. Yeah, this project.
Oh, I know what's happened there.
Yes, it's a ruse so Rachel doesn't do a VOD. So then
Tough, I'm doing the VOD anyway.
Yeah.
Sorry. I don't make the rules.
You make that rule, and I want that rule changed.
No, I don't make these rules. So apparently it was trying to write a copy of the library file back to your pool.
What?
I think you did something a little weird with the library file for Yumekui.
I set it to be a project library.
I mean as in like path. I think you've got an absolute path in there.
Oh, that might have to change.
Yep.
Yeah, just you'll have to edit the VOD, Rachel, to bleep out the secret.
Yeah, disclosure agreement.
Yeah, disclosure agreement. Oh yeah, I bet Obliterus. Not that Obliterus can hear me.
Well, it's okay. Obliterus will be able to catch it up on the VOD.
Let me do a thing.
Disclosure agreement. All disclosures must consist only of yeah. Right, where was it on your pool? Projects.
Okay, I removed the
We...
I removed the cooldown for the nya command.
Oh, that's dangerous.
Yeah, please,
Freya's awesome.
please.
I love it.
Alright, and this will be the ULPI interface.
Is the library file? Like, did you stick it in Etsy or something?
Yeah, it's in the...
Oh, okay.
Oh, that was my neck.
Yeah.
Yeah.
So let's do manage symbol libraries, discard changes because it's a thing. Yeah, you just put a straight up absolute path in there.
I
GG.
did not put that in there. Keycat put that in there.
GG.
You know me. I try to avoid absolute paths wherever possible.
I know. I can still tease you.
ULPI. N6. Bidirectional.
So this is actually Kai Proj mod.
Yeah.
Slash dot dot slash dot dot.
Well, when this project's under source control on 2 separate machines, and it's just
Yeah, that gets bad in a hurry. I hope this isn't about to crash. Expecting open round. What?
What did you do?
What?
What did you do?
I don't know.
Well, I sure as hell don't know. Fine sounds are fine. Exasperated cat sounds, yeah, really.
Yeah. Oh, I know what I did wrong. I'm using the .lib rather than the KaiSim lib. Sorry, KiCad simlib. I'll get this right someday. There we go.
Together. That is.
There we are.
Only ULPI.
So we change symbol with the Yumekui version I've just updated. Yumekui. Rather, because I can't pronounce apparently.
Yep, because...
Yeah, the don't use is a whole thing. That was a little terrifying of what happened.
A little terrifying.
Okay, a lot terrifying. Shh.
The
Wagon
solution...
can understand.
truncate, just disable swap entirely. Oops, that should be bidirectional.
Hmm. Yeah. I'm getting a head pat in my chat, apparently. Oh, that was actually a little while ago. Whoops. Sorry, HexGen. I'm trying to figure out why this didn't update. Oh, no, it did. I just didn't... Ooh. Ha. I see what's happened.
What did you do?
I'm just having some extra fun here, that's all.
Yeah, again, sorry my stream's more boring. I'm just making part.
I mean, mine's been incredibly boring too, so, you know what?
Buy mode 1.
Yeah. Anyway, the lovely cat girl who's hosting the stream makes it infinitely less boring, right?
Not allowed. Compliments not allowed. Compliments banned.
Oh, compliments perfectly allowed. Yeah.
Which is pin A12, which is...
So what is comp supposed to do in this case? Oh, it's for a compensation network, okay. Yeah, the problem with Obliterous was that it didn't matter if you were using a swap file or not. If somebody else was using that branch and they were using a swap file, they were screwed. Whoops. So it's like, for the greater good, we'll just ignore that happened.
Thanks for the follow, B. Berkey.
Woo. See, I told you we would sort out the fact you've not got as many follows as me.
I don't care. I don't want... I don't... Yeah, help. My wife is bullying me and I don't know how I feel about that.
I wasn't a bully.
That was very much a bully.
No, no bully. I wasn't a bully.
Something, I'll J your tag.
Yeah, fame is overrated. This is true.
PMS.
Just having to make a little more room for a compensation network and for some of the other routing I need to do.
Compensate your network?
Lewd.
Oh god, don't remind me about ooms. I have 128 gigabytes of RAM and I still oom sometimes on compile jobs.
Yep. Kinda mental. But awesome.
Yeah, I had an instance on, I was trying to synthesize a DDR3 controller with Yosis, and Yosis just kept inhaling RAM forever. Like, I didn't even get, ooh, it ran my kernel into swap almost. It was that bad. Like, it filled up 128 gigs of RAM, and 8 gigs of swap.
Yep.
It was double plus ungood.
It was very extra.
Yeah, I don't want to. I should run early but I don't want to run more Blurpity of Optibit. That made sense, I promise. At least it made sense in my head.
It's all good. You find it hard to use less than 10 gig. I find it hard to use less than 16 gig.
Oh gosh, don't even.
Actually, what is my RAM usage right now? It's terrifying. I know that.
I'm currently using 35.
Oh, that's light. I'm using 44.9. Ah!
Well, duplicate in that location. Unit C and C.
It's a good thing that Aki persuaded me to get a lot of memory for this machine.
Oh yeah, I convinced her to upgrade.
It was a good choice.
Group link. F3, did I put that pin in it? Alright.
Yeah, I have 64 thanks to my wife being just awesome and amazing. Needs more sheep instead. Oh, that's great, Hex Gen. Thank you. Oh.
N6. Okay, it looks like all these pins are just things that exist. Oh, right, I need units.
Soon, TM. Gift that keeps on giving, right?
SS.
Sorry, calling you out there, I know.
SPX plus, which is on page 14, and it is outputs. SSTX. SSTX.
Take care, Obliterous.
Bye bye, Blit.
Thanks for coming and hanging out with us, even if you couldn't hear. For now.
Yeah, but FX minus, which is pin number F14.
Oh, this is gonna be fun. What is the compensation network required? I have no idea.
This is plus 14. This is bidirectional. Minus, which is 15, which is bidirectional and inverted. And this is bus. Be bussy.
That's interesting. For a given input voltage, upper and lower limitations on the output voltage exists due to the minimum on time and minimum off time.
Oh.
And I have to skip a tune. That's gonna suck! I hope I haven't got too high an input voltage then.
So what would the problem be? Dear. Dear.
Well, I've got to run some calculations.
What's the theoretical problem?
That we don't have the ability to go down to a low enough voltage.
We would have to pre-regulate the 12 volts down into something and then regulate that. I kind of anticipate something like that might happen.
Well, I'm hoping it isn't gonna happen. I'm hoping that, like, I can massage the numbers.
I mean, I won't be upset if it does happen because I figured this would happen.
Well, so one of the things we have is we have FSW, which is the switching frequency, and that actually helps determine the minimum voltage. So we have a Vin of 12 volts by the T min on, which add more hertz till it hurts.
More hertz till it hurts. We're already running.
That's terrible. I love it.
You're running fast. It's gonna be doing gigahertz.
Please, dear, I was drinking when you said that.
Said what? Gigahertz?
Mm-hmm.
R1X.
It's making me laugh while I've got a mouthful. The minimum on time for channel 1 and 2 is 117 nanoseconds.
R1X.
I don't know how I set the switching frequency, so there is that. I'm
Oh,
gonna
God,
go
so-
with 500 kilohertz for a second.
So Analog Devices has a quote-unquote design application for these parts. And it's just a monstrosity of an Excel spreadsheet with macros.
Yeah.
It's absolutely terrifying. PDDA1, P1.
RDS on 1 is the resistance of the high side MOSFET, and RDS on 2 is the low side. Okay.
RS.
The... Nice.
Same timings is good.
So the high side is Q1 inside the device. The low side is our external one. It is... Well, so Steffi, unfortunately that's not true with this kind of shit. Given the work that has been done with Ryzen, and the fact that you're using a Ryzen 5000 series part, it should be fine. If you are on 3000, 2000, or 1000, then it matters a lot. Yeah, and I really need to point this out, Steffi, because memory is not memory on desktop. It's fucking weird. I hate it. It's bollocks and bullshit.
Yeah. I mean, also, Zen 1 was really picky about its memory.
Yeah. The memory timings thing is just a minefield. But on Ryzen 5000, it should be fine. They don't lie about ECC, they do support ECC. It's the motherboard manufacturers that are the ones that are being cagey. Oh, okay. The typical switching frequency, if we put RT as 25.5 k ohm, is 7,400 kilohertz.
I think that's... Power ground. Okay.
Yeah, it's all about the motherboard though, Steffi. A lot of consumer motherboards don't actually enable it, which is really annoying. And it's stupid because it's easy.
We'll be right back. I need to get some water.
Okay. Talk to you in a moment then. Yep. But my motherboard here, the one I've got in my machine right now, can do ECC memory. It's the Gigabyte X570 UD, I think is the number. Should be able to do ECC. That is...
Yep. Und back.
Welcome back.
Oh, I have an Elgato Stream Deck. I should set it up so I don't have to keep clicking into OBS.
It's a whole thing.
Also got...
There we go. 7. Support
one.
for ECC unbuffered DIMMs. So UDIMMs. And I can do that quite happily with 1 or 2 rank by 8 modules. If I want to. Yeah, our DIMMs don't work in this motherboard, UDIMMs do.
Whose DIMMs do?
You know exactly what I'm talking about there. You know exactly what I meant.
I'm sorry, that was such a stupid joke.
It's okay. That was quite funny. Yeah. Registered and unregistered is a whole thing. Both for ECC and non-ECC and just... It's a whole thing. Right. Oh right, I was trying to do a formula. I'm getting a little distracted, sorry.
What if memory, but fast?
So as the RDS on for the high is 100 milliohm. I love the fact I'm able to do units aware calculation.
Oh yeah, Rink has made my life infinitely easier.
Yeah.
I wonder how Tiff's doing. I should say hi in poker.
Yeah. We should both do that. What is the RDS on for this big chunk effect? It is...
Yes, Rink is absolutely fantastic.
20 milliohm. Ish. I'm going with a round number figure here. Because I need to go with a number.
All round
Just
your number?
back of the envelope calculate this.
It's in cargo. You could probably... It's Rink RS on GitHub. Yeah, I can...
Oh.
I can link.
Oh yeah, thank you for dealing with XGen's request. Yeah.
It doesn't have all the units, like it doesn't have DBM, unfortunately.
But it's got a lot of them.
Yeah.
How did I know that that was gonna tickle you pink? That is the AC and DC switching characteristics. We want that one too. Hmm.
Okay, I think the last thing I
Oh, that's just
have...
another copy of the same data sheet. Okay, whatever.
Oh.
I need some currents.
Black currant jam sounds very tasty right about now.
Hmm.
Just a random thought for everybody.
That was cute. So, the quiescent current is an amp for this thing.
I think it needs more current.
I'm intentionally not accepting use of cookies. I do not acquiesce to this request.
I'll accept your cookies.
Lewd.
No?
Blockgrams want 19 milliamps. Yeah, so we'll call that 1 amp.
I just for some reason I want to build like a 300 amp 1 volt supply. I have no use for such a supply, but
Say that again? How much current? What voltage?
300 amps at 1 volt.
Oh, okay. A welding supply. I dig. Oh. That's a lot of current. That's because it is a welder.
VDD A333 pin number 12. It is power in. This is power in. Be a good pin. Oh god damn it. You know what I should have done? You know what I should have done?
No.
Shoulda, coulda, woulda.
Oh. You got Vn times tmin on times switching frequency minus the RDS ons by the current by the switching by the tmin on again. Oh, okay. And then again by the switching frequency minus the bottom RDS on plus the resistance of the load. But I don't know what the resistance of the load is going... Oh, the resistance of the output inductor. Sorry. What inductor have I used on the board I was building last night? One moment while I go and grab a part. Sure, we'll go with those ones. This is ballpark maths anyway. Back.
Quick maths.
Yeah. You know. If it's good enough, it's good enough, right?
Yeah. What?
So we've got...
Cookie. Nom 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 cookie.
418T. Very cute. Huh. These are Tayo Yuden? Huh.
Oh.
Tayo Yuden. Okay, it's the cut tape version I want. And this gives us a DC resistance of 50.4 milliohm. That's tiny. It's great.
What about the reactance and the reluctance? What if the core flux density?
Yes, dear. And this is by IOUT min again, so 1 amp. Oh, okay. We just squeeze in there. Our minimum voltage that we can generate is 962 millivolts.
Oh wow, we are just there.
Just threading the needle. Oh.
Well, to be fair, we do have like plus or minus 100 millivolts.
It will work. Don't get me wrong. It's just that's a very tight needle I'm threading.
Getting by the skin of our butts.
Uh-huh.
This is L5.
I can't. The 5-volt supply cannot provide enough current.
Yeah, so the issue we have is just current density.
Yeah.
So we're providing 8 parallel 12-volt in, which is gonna provide, I don't know, what do you think? How many amps does that have to be?
I don't even want to contemplate that right now.
Lots. It has to be lots.
Yeah.
Just because these Kintexes are going to just gobble power. I'm not happy about it, but that's just how it is.
Yeah. Which bit of the... Oh, right. We're done with that. So current limit setting.
What I desperately want is Xilinx to take...
Welcome back, Freya.
Welcome back! I desperately want Xilinx to take their higher-end transceivers, like even the Versal ACAP 58 gigabit transceivers, and just bolt them to a medium-range ARTIX for me. I don't need all the gates. I just need fast.
Yep.
Gotta go fast.
Table 12. That's what we're looking for. Oh yeah, that will help a lot. Same manufacturer, different revisions of the kit, definitely helps. I see they tell me, go and look at table 12. There is no table 12. Oh, actually, no, it's just way far above.
Yeah, that's a bit.
Fuck them. Floating. All-in-one floating is what we want. Oh, ooh. Ooh. Or I can put a 22k resistor in there, and we can have up to 6.4 amps. Ow. I think I might do the 22k thing.
Fine.
Where are the limbs?
You sunk my battleship.
Indeed. Oh, these aren't a pin, these go between... Oh, that's why I'm getting hungry. It's getting to Rachel's supper time.
Oh.
Oh.
No, I want it to be one. F2. K2.
Glad to hear that, Freya.
P4.
Yeah, these go between DL1 and power ground and DL2 and power ground. That's how they've done it. There's what I was looking for. It's on the first friggin' page.
10, 10. Yeah, I do not like that datasheet.
RLIM1 and RLIM2 go between gates of the low sides and power ground. So let's throw a resistor in, I guess.
Okay, see you soon, Freya.
Take care, Freya. Gambatte ne.
Oh, so to update chat, so I have in the works a live 2D plugin for OBS that runs natively on Linux and isn't complete garbage. So that you'll hopefully have that in the future once if I can find the money and someone to commission a
Avatar.
an avatar. What is that for, plugin? What? I'm not quite sure I understand the question. Oh, these are just the power pins for the USB transceiver.
They are extra.
Yeah, they're kind of extra.
The transceiver itself is also kind of extra.
Yeah, they're all going to be stacked. So,
Click the wrong tab. Go to me. Yeah, 22K.
Oh god. Gosh darn diddly damn it. Fuck. Right.
What?
I just have to mark 1.5 bazillion pins as passive.
Oh. Yeah, that's, I understand your pain.
Once I get this part done, I actually have to do the, finish working on the zinc. As well. So, my stream is nothing but kind of like maintenance and that kind of stuff.
I'm still designing the first channel of the DC-DCs. So, yeah. And we've been going for 2 hours.
That's perfectly... I have problems with pop.
We're designing different parts, my Aegis. I'm designing power supplies. Aki is designing the components that these power supplies go into.
Yeah. I'm currently working on the USB transceiver.
Yeah. So she's working on getting data out the device. I'm working on making it so the device even powers on.
Which is arguably the most important part.
No. You're doing important stuff too, dear. Without both things together, it don't work.
Yeah. I'll have to poke Eston about his prowess on crowd supply to see about
Yup.
getting built. Maybe do a crowd supply campaign.
That would be really cool.
I
support that wholeheartedly.
I think there's a market for it, but they're not going to be cheap. They're going to be expensive.
Yeah.
Like, even the prototypes are going to be ungodly expensive.
Yup.
But then if you move into volume manufacturing, these are not trivial devices. And I don't know if
We don't need Barrett works on magic and lots of dreams, apparently.
Yeah, that's true.
I mean,
Yes.
it is called Dream Killer, so I mean, I guess that works.
That is Yumekui is the code name for the project, which translates to Dream Eater.
Dream Eater, sorry, yes.
So, yeah. Crunch.
D is the duty cycle. Ah, okay. More formulae! I am going to copy some stuff into KiCad before I forget to show how we
feel free to
calculated things.
Add notes. That's fine. Do that. I am tempted to make a Python calculator for the ADP 5050 because we use it so often.
I support that.
And we can just tell it, here are the voltage rails we want. Gib.
Gibbs? Okay.
Gib. Oh, I should have been marking these as invisible while I was doing this. Do it. Make it. Make what? What? I don't understand.
Do it. Make it. Platypus wishes us to make this thing.
Hour after hour. You've got that Daft Punk song stuck in my head now.
Which
Buy
one?
It, use it, break it, fix it, trash it,
Oh! That's a good
also
song
harder,
to get
better,
stuck in
faster,
head.
stronger. They're both kind of like simultaneously occupying the same part of my brain right now.
Are we?
It's not your fault. It's Platypus's fault.
Alright, yeah. Actually, I should probably say what this is.
You think that sheet will be big enough for 3 layouts?
I don't know. We'll see. What's that, Platypus? Are you asking me about the calculator I'm using?
Oh, no. For the ADP 5050. I think that's what they're talking about. Am I correct in that assumption? Yes. Hi, Mina-san, genki desu ka?
Genki desu.
Hi. Hi. I need to get back into my language studies. Quite
Same.
really. Passive. Just Zen circuit board screen. Yeah, I think what I'll do for the prototypes too is we might have like a buy-in pool.
Oh, that would be cool.
So we're doing 5 prototypes, and I will essentially divide the cost to make them. Take the total cost of all the parts and everything, divide it by 5, and then if someone wants to buy in, they would do that 1/5 the cost plus shipping.
And that includes a fair way to do it.
The case and all of that jazz. Oh, I wonder if I could get the case people. I think they only do monochrome printing, but if I can convince them to do multicolor printing, I will totally get them to put a flag on the back.
Yes. I approve wholeheartedly.
Round A. I won't bother with switching to visibility right now. Yeah, I haven't even started my Anki deck, so...
Neither have I. Oops.
15. 15. That's 13. 13. L12.
Yep, there's some parts. That needs to be centered. That away.
M12. No, bad. M12. M13.
8 viewers. That's not too surprising. I am being very, very boring right now.
I'm being boring too, so...
Yeah, you're fine. I think I want the first ADP 5050 to be... its SW2 to be doing the RAM on the left side of the board. Because that wants a lot of current too. Ooh, I should go and find...
Find somebody to love.
Where is the RAM?
Okay, Steffi. I'm not.
FPGA 1 memory. Aha. Oh. Good, good. I should go and sort myself something to eat, but, I will go and sort myself something to eat shortly.
Yeah.
I just want to try and find the voltage required for this first, and...
Oh, are you just looking up the part number for the RAM?
Yeah. So this is the 1.35 volt supply.
But it's also 1.5 volt tolerant.
Kind of. So the supply voltage given is the nominal, please give me this to run me at my prescribed frequency, etc. So I'm going to design for that power supply voltage and we'll be good to go. But technically it can go all the way up to 1.45 volts. It's not fun to do that to it, but you can.
Clock the RAM.
No. No. Oh, you didn't put a supply in for that yet.
What do you mean? Yeah, no, there's not a thing for that yet. Because I wasn't sure what voltage we were going to be running the stuff.
Oh. We do it at the prescribed voltage. Trust me on that.
Prescribe your voltage.
So 1.35 K7L, 1.35 K7R.
No, that wasn't what I wanted. That was what I wanted. P11. F12. Okay, I think that's all the pins.
Yay! God, the resistor divider for this one's gonna be weird.
Well, mind you, yeah, we've got a. We're also limited by the availability of resistors, so.
I know. The 40k is actually going to be 40k too, so the voltage on that rail is going to be ever so slightly off, but it's lower, not higher, so it's fine. Unless we go to like 38k9 or something like that, and we go for a very slight over voltage, but it's very minimal. I think it's within tolerance.
Yeah.
We'll do the maths and make sure it is, don't worry. I'm not about to blow the arse end out of any of these devices. I'm not like that.
Good, because you know how expensive.
Yes, I do.
Reworking this board is going to be damn near impossible.
Yeah. Apparently this wants to be approximately a 14.545454 resistor. K-ohm, that is. I hate this.
999.
Yeah.
I can totally tell what pin that ground is connected to.
Nice. The actual voltage we're going to produce for the RAM is going to be most probably 1.351724 volts.
That should be within spec.
Yeah, exactly.
Just barely.
It's good enough. And if we want to tune it, we can actually change the resistor divider slightly. We can change the top resistor to not be 10k, but something else.
Why? Here's a brilliant idea. Why don't we hook digital potentiometers up to those lines?
No.
And then we could program the voltage.
No. That's a terrible idea.
I don't see the problem.
Welcome, Funaku. I don't know. Aki is designing parts for a PCIe Express analyzer by 16 3.0, and I'm designing the power supplies. I'm also streaming at the same time on another channel.
Yeah, it's a tandem stream.
Simey stream!
Why does that happen? I'm not pressing any key to trigger that. It's just showing up.
Huh. I don't know.
But yeah, it's a PCI Express Gen 3 6. It can operate in 1x4, 4x4, 2x8, or 1x16 modes.
It's okay to not understand.
I don't understand things either. It's fine. Oh, you weren't supposed to be invisible. Oh, that's a keycat thing. That's though all the pins are stacked and I don't have a bazillion pins in the symbol. It's just an organizational thing. To make it look more pretty. Because nice looking parts are important.
Yep.
Ah. That's not what I want.
That's a lot of documentation for one resistor divider. I hope you're happy with yourself. You made me write a mini essay as to how I got there.
There's only one of those. Okay, that one needs to be power input as well. That's power input visible.
Okay. I hope that actually does make sense. Like, it's not pretty.
Oh, yeah. Are you sure that was me? Because, cool, but I don't fucking remember that. Sorry.
NMI Gen is great. NMI Gen's awesome.
I've just got the shit active memory.
She also got me to learn NMI Gen, and oh, I'm so glad I did. Cause, yeah. It's a thing.
Okay. I'll trust you on that.
Aki, good cat girl who needs pettings and pats and...
Yeah, not in front of the company.
Definitely in front of the company. Good, right? Yeah, she was working on... Yeah, you caught that stream.
That's still in the works.
You have got it pretty close though, to be fair. It's looking really, really good.
It's close-ish. But yeah, NMI Gen is definitely worth learning.
Mm-hmm. Okay, so inductor selection. Let's quickly run the numbers for that, and then I'll get myself something to eat.
That sounds like a brilliant plan.
So we've got 12 volts in, 1 volt out, with the resulting duty cycle of 1V divided by 12V.
Clear. Got the core. I've got the ULPI interface and the chunky A pipe interface. I think all of it.
It's good. What do we want the inductor ripple current to be?
Small.
30 to 40% of the maximum load current. Oh, we don't even know what the maximum is. Technically. Let's go for 6 amp. And that makes for 0.3 by 740 kilohertz, because that's the switching frequency. Oh my. 688 nanohenry inductor. I don't think they make them that small. That's slightly problematic.
Yeah, slightly.
If I set the ripple down... Oh, okay. If I set the ripple to like 10%, which is far more reasonable, I think, anyway, then that goes up to... You make your trace slightly more loopular. That goes up to microhenries at least. 20.6 microhenry for a 1% ripple current. That's a very nice switch to my power supply at that point.
Yeah. Are we gonna be able to find an inductor?
Well, at least it's in microhenry now, so yes.
Yeah, just do on PCB inductors.
Let's not. All products, passives, inductor. We want fixed value inductors.
We don't want... Okay, this wants... 1V...
Oh, okay, they do actually make them in nanohenry range. They're just... There's not very many of them.
I can't imagine why.
Oh, I'm not surprised that someone has. 22 microhenry, but there's only one of them. Oof. And that's from TDK!
Oh, fun.
That's actually really nice. What is the maximum current it can handle?
Hopefully enough.
Yeah, really. I need a minimum of 6 amp. Ugh. 22 microhenry, ISAT, 2.1 amps.
Oh!
That's
We
not
might
enough current.
I need multiple inductors.
That's not how it works.
We might have to gang.
Please, X-Gen, that was terrible. I love it though.
Excuse me.
It would be a very nice small inductor though. Like,
Yeah, but
I'm
it's
just
small,
gonna share
so
this with you. Cause cute.
I will give it a look in a second.
Ah. At least they got 1,000 in stock. I'm gonna go DigiKey for this and see if I can find a more sensible inductor there. Inductors, coils, and jokes.
I'll show
Fixed
one
inductors.
inductor.
Lewd. Dear. So lewd.
I guess.
Oh.
USB 3.5. Yeah.
And then I'm getting binged. Hello. Oh. A whole pile of people joining me on Twitter.
Oh. This is power
Alright.
down. Oh. I should read what those pins should be.
Probably. So it looks like I'm gonna have to go for a 22 microhenry inductor. Just to go for a common value.
Okay.
But that's
What's that?
fine, because that actually gives us less ripple current through the inductor still. Which
Cool,
is
but what's
good.
What's the hit to the amperage?
I can go all the way up to 49 amps in saturation current if I need.
Okay, that's fine.
And 40 amps for a current rating for the inductor. They just get big.
Yeah. Chonky AF.
DigiKey actually has a reasonable range of inductors. Who knew? Right, I am going to do the BRB thing and get myself some food. So I will talk to you all in a little bit. I will still be around to talk on Aki's stream. I'm just going to BRB my one. Well, that's got 7.5 minutes to go, so I might as well continue streaming.
Yes, that was Rachel doing microwavey beepy things in the background.
Sorry.
Show microwave on stream? No. Also, I can't.
I don't have my camera set up right now, so...
Yeah, she doesn't have her camera set up, and I'm 3,000 miles away. Unfortunately.
I wish she was here, because then I could actually hug her, and the living situation would be a lot better, and just...
I wish I was there too, so, you know.
It's a whole thing.
Yeah, pandemic is not fun.
Nope. It's been very, very brutal on both of us, and it's not good.
Show me your
wacky sticking.
glue.
How was that lewd? Show me the lewd.
I didn't say lewd. Oops.
Well,
alright.
fair enough.
VNA mic, yeah. Who doesn't want a VNA microwave? I mean, who doesn't want a VNA in general?
Well, anyone who doesn't clearly got have their head screwed back on the right way around, because, you know, VNA.
Oh, crunch goes Aki's neck.
Oh.
RX data. And then I'm just gonna copy pasta this a bunch of times.
Okay, that's close enough. I now know about what the ripple current is. I could have solved that a different way. Oh.
That's all good. What's a rickroll? Oh, please.
Please.
And I think P clock was in here too. Yeah. Oh, that's 1 second.
So we got...
I showed you my microwave. Please respond. I also just
Delta
noticed
IL is aimed as being...
Yeah. I need to edit that footprint because that's off.
One percent of 6 amps. That's what we set Delta IL to.
No, that wasn't what I wanted. That was what I wanted.
It's the amount of current that will go through the inductor during the charge and discharge phases. So you've got the continuous draw, which is the amount that the circuit itself is drawing, and then you have the ripple on top of that caused by the switching, which changes things like what the output caps need to be, etc. So it's the amount of ripple on top of the continuous current. Of course, by turning it on and off really, really fast.
And then these will be...
No, that one's the wrong selection. It's this one.
Sometimes.
Nice.
That wasn't what I wanted. That was what I typed.
I'm just trying to think about how I rearranged this formula.
Don't throw it into Wolfram Alpha.
So I can solve for delta IL. I think I take the inductance.
Did you just make it like Twitch meow? Yeah.
Hmm?
Yeah.
Twitch just meowed. Don't worry, it's fine. Meow! Meow! Because I might as well meow to my music.
Cute. Wife is cute.
My wife's cute. I don't know what she's talking about.
What was it? TX dem? No, TX margin.
So what we're aiming to do here is we're aiming to put everything on the L side, so we just have delta IL. Which means...
Q on the L side? Nothing.
Okay. 1 over inductor is the delta IL part over this.
God damn it, Andy.
So if we know what the conductance is, we then take our 12V in minus 1V out multiplied by 1 volt divided by 12 volt for the duty cycle. Now we just have delta IL FSW on one side. And I have to skip this one. Oops. And then 470 KHZ.
Don't bully. I made deserve. Don't.
That's an interesting unit.
Yeah, what unit did you get?
I got approximate Siemens squared per ampere.
Interesting.
I think I did something wrong. Whoops.
I mean, that vaguely sounds like it could be a current unit. Area per amp. No, it's not even area. I don't even know what I'm talking
I
about.
don't know what this unit is. Wolfram Alpha.
Yes.
Let's just Wolfram Alpha it. We have 22 microhenry is 12 volt minus 1 volt divided by 1 volt divided by 12 volt by 6 amps by an unknown by 740 kHz.
Hey, look at that. Why did it open that up? Oh, you're mad about those. Okay, client save schematic.
Let's just use X, not A, so it doesn't try and interpret that weirdly.
Oh my god, okay, I finally have the pipe rooted.
Amperes, volts, good. 22 microhenries is this godforsaken thing. Oh, hang on, did I... oh, whoopsie, I copied something out here wrong. Multiply that there. Yeah.
Oh gosh, do I hook up RX to RX and TX spirits on the connector? I don't actually know.
Yes, you do.
TX to RX and RX to TX.
No, they're the correct way round.
I
think you'll find that the correct way round.
Okay, but this is gonna be annoying if they're not.
Yep. So V in minus V out multiplied by the D. V in minus V out multiplied by D. Yeah, okay. So I have got this right now. How do I tell this that I really want it to output in a decimal form?
You should be able to click it and click the result and it'll for approximate.
Okay. 0.009384834834. Okay. Yep.
Oh gosh, what does drain hook up to? I don't actually know.
That almost sounds like there's a MOSFET inside there. What?
No, this is on the USB 3 connector.
Yeah, like I said, that almost sounds like a MOSFET's in there.
Yeah, I don't know.
Oh my god. Let's quickly try and...
I'm thinking about wrapping up here because we've been streaming for almost 3 hours.
Fair.
And I like to keep my streams short-ish, so... I mean, we got stuff done, so that's good. I have to fix a thing. Of course I have to fix it again. Power unit.
Okay, having finally fucked around and got the right number there, I should also go and get my supper out the microwave.
Well, I think that's actually a good place to stop.
I mean, I would like to try and finish a channel of the power supply.
I mean, guess you can keep streaming if you want, but I think I'm gonna wrap up because we got a lot done, and my stream spoons have been exhausted.
That is completely understandable.
So yeah. Yeah, well, it's not that you finally managed to catch one, it's just I don't stream very often. I don't think I've streamed in like a month or two. So,
It's been a little while, yeah.
This is just how it goes. I'm gonna wrap up. Rachel will still be streaming work on this. I will unfortunately not be on call, so because I'm gonna finish lunch, which I never actually got to finish before stream.
Yeah, please do finish lunch.
So...
oh my god, this does not tell me what out is.
Yeah, you can all go join her. I'll probably see if I can set up a raid or something.
Oh, my wife doing a raid of my stream? Oh!
Just to punt everybody over there. But yeah, so thank you all for stopping by, and I hope you enjoyed it, even though we didn't get a lot done. We still got some stuff done.
I think you got a good amount done. You got all those symbols done. Come on.
Yeah.
They're time consuming, that's the thing.
Yeah. Oh, I've got to do the whole... Okay, hold on.
Patreon supporters.
Yeah. I have to do that whole thing. Oh.
Okay, as it's the peak inductor current, I'm going to go with 6 ampere as I out.
Yep. Okay. So yes, I'd like to thank all the people doing the supports on the Patreons. It means a lot, especially because I'm currently out of a job and I am looking. So you all
you're
have
out of a job, and you've got a job.
I've talked to you about that. I don't want to get it.
I know.
Yeah, so you all basically bought me groceries and let me eat. So that's very nice of everybody. I'd like to thank DX, Steffi, Matthew Hansen, Erica, Rachel White Quark, Omni Technomancer, Ezekiel Bethel, Jessica, 1-Bit Square, that's Esden, Mianotech, and HexGen for supporting me on Patreon. It means a lot. And you all bought me this lunch that I am about to finish. So thank you very much. And yeah, have a good day. And I will talk to you later, dear.
Indeed. Talk to you in a bit. I am invaded by oh my. We are currently doing calculation of currents because this thing's a little gulpy. And having hilarious fun with windows because they're hard to organize. Let's try SQRT. Yeah, okay. Square root of 6 amps by 6 amps. Yeah. Oh yeah, this is just the whole thing. Oh, thank you for the follow, Funaku. Welcome to the stream. So, I don't really know what my delta IL is as such. Yeah, but I'm not yet finished writing the formula. Yep. And this is over 12. So I think what I want to do is I want to do 6 amps. Can I do... I'm sorry. Fun AQ? Is it? I don't know. No, HexGen, not idiot. So that's apparently my RMS current. I love how it says approx, because it's had to do an approximation, and it's just like, yeah, I don't know for sure, but this is ish the number. Oh, I hate that KiCad keeps doing this. I'm using middle click, and it keeps deselecting text on me, because that text is... No, HexGen, not an idiot. Because it auto-selects this text size bit, which is really annoying. Wow. Pardon me. So we need, Oh, that's interesting. I should double some numbers. Sorry, not double. Multiply by 10. We want 9.38 here. And why will become apparent in a moment. Okay. So this takes us to... there we go. So we're gonna go with 10%. What was the 10% calculation actually for this? Let's actually do it that way around. 2.2 microhenry. Solving, we get 9.384. That changes these numbers. Yeah. I'm sorry, dear, I don't have that yet. I know, I really should reconfigure Streamlabs. I think it is, yes. Helps if I copied the correct one. That one. Okay, there we go. So the reason we've done this is because otherwise the inductor would be a bit redonkulous. Using this, I could use their stock Coilcraft part, which has enough current for what we're doing, ish, Sorry, this one here. Which, yeah, can handle what we're doing. 6x6mm. Or we can go and search for one. So if we go and change... No, but they're a good company. So if we go for a 2.2 microhenry inductor. Normally stocking. Because I don't mind if it's not in stock right now because of the shortages. It does, this is true. We're going to set a minimum current rating of... And this is where those numbers we just calculated come in. 1.3 amps. Sorry, 6.3 amps. And that gets us 765. Ah, it's cute. That's 8 and 12 amp. I think it's nuts. That one's 8x8mm. That's kind of chunky. Jeez, the currents that you can get. Murata. They make good parts. What's the Murata one? 30% tolerance though. Oof. That's also an 8x8mm. I have a funny feeling that could be it, yeah. We want cut tape. That'll help get rid of some of them. Kappa ore. Jeez. Iron powder. Ooh, right. We have to be careful about the core material. Oh, those are cute. Those are wire round. $12mm. Jeez, I don't need them that big. I agree. Let's take this part number and throw it into DigiKey directly. Great! I love it! By which I mean I hate it! Nah, you wouldn't. Okay, 6x6mm is probably our point. Let's get rid of the Farnell tab because that's useless. We want surface mount. We want shielded. Yeah, we want shielded. We do not want a tolerance more than 20%. And we want either dash or ferrite. So that gets us... Ooh, Vishay Dale parts. And not too expensively huge on the board. Those are some rather fancy looking ones. I'm gonna get rid of the Corm type for a moment. Oh, of course, Coilcraft doesn't exist anymore. Ah ha ha. That's why that happened. We don't care about those ratings. Verth, Vishay Dale, TDK, Murata, Kamet, AVX, Borns. And I need to filter on size. I'm gonna filter on these smaller sizes. Because otherwise it's gonna be a bit big on the board. Actually, those ones are still a bit big. Actually, I'm going to undo the manufacturer one for a moment so that we can undo the size dimension filter. I've got a reason for this. And that is I actually want to filter all 6x6 and smaller, which is already going to heavily filter down what we get. I don't trust Panasonic for this. Okay, Vishay Dale. Borns. Ooh, that's a nice Borns part. Oh, and it's really small. Excellent. 7 amp, 8 amp, 20%. Hey. That's just metal core. It doesn't specify beyond that. That probably explains why the saturation current is so low, actually. Oh, we should have specified that ISAT had to be more than 6.4 amp. Oh, there's a Kamet one there as well. 5 by 5.3. Oh, I forgot to update Streamlabs. Whoopsie. No, this isn't Opal Sniffer. That's cute. But I think I'm going to go with the Bourne's one I've picked, because that seems to match all the criteria we need. Alright, it's 32 milliohm. I hope that doesn't screw up this. Because that number needs to be redone with 32 milliohm in it. What does that come to? Oh, yeah, that gets us very close to the limit. But we're in scope, so... This is a value of 2U2. So we need, this is a MFR NPN URL digi-key. The usual ones I use. I'll let Aki fix that if I've done something wrong. Which also gives us a OC digi-key. So this is a Bourne's Inc. And that godforsaken thing is the digi-key. I am dear. I've optimized this to keep it as small as I can. Yeah, obviously. So we want footprint for this. It's all good there. Do you mind if I use... Oh, my my library won't have that small, will it? Haha. Okay. Does Aki have... Oh, come on. Do you have capacitor footprints, or are you just using the stock built-in ones? Okay. Well, I'll go find the RCL library then. Oh, that's an Eagle library, sorry. Capacitor SMD. Resistor SMD, there we go. So you want me to use 0402, right? Yeah, got it. For these resistors, that's easy. Capacitor SMD 0402. Mm-hmm. Yep. And that doesn't have a footprint set yet, but you said you've got one in the library. Yes, you do. Excellent. I'm gonna do a quick import test just to see how this works, because I do need to do an annotation though. Is that one? Update PCB. There's no duplicates? What? Oh, for fuck's sakes, because I did the annotation only on this sheet. There we go. Now it did the right thing. That's fine. It's cute. They're so tiny. I'm on a 1mm grid and these things are still just so cutely tiny. But actually, ooh, that's on the fab layer anyway. Let's just quickly turn fab off. Well, that fat is just enormous, right? Same. Also, nix the designators. Okay. I'll throw them onto fab as well. That pointer. God, the moment where your wife has to tell you to stick stuff on the fab layer because we just don't have space enough. Yeah, that's the kind of project we're working on. I'm also going to do it with the converter itself, because, yeah, I don't think we really have enough space there either. Ah, this is the divider. Ooh, right, this is the divider. Actually needs to go over here, like that, to have access to the output voltage. Something like that. It's well grounded. Yep. Good fun. Oh, that's not good. I can't root through that. Oh no. Oh no. That's the smallest we can go to, isn't it? Oh. Well, that's tiny. Oh, track clearance 1mm. It's 1.27 for this. Along with 1.27 there, right? File size is way smaller than that, because we're on a tiny process. I'm just gonna bung in the numbers I know, but I know that these are huge for this process, so... Ah! Yay! Just fits. Yep. Well, that's good enough, right? Oh, that's awesome. Ah, whatever. Okie dokie, take care, Freya. Oh, stop! Stop. No. Keycat, please. Please! Stop. You are extra. Stop being a diva. How is... oh boy. Fine, I'll leave it there. What I actually want it to do is route into here and then down and across so that we don't get the bad geometry there. Also, these are not big enough tracks right now. Welcome to DC design. See, these are the big power traces, so actually that needs to be one of these. No, they're not. This is a sense, yes. This is the cap that makes it all work. It's actually got quite a lot of current it has to see. I need to name the switching node L1V0 K7LSW. Thermals are going to be huge if I do that. 2 and 4. Minimum width 2. Delay 0.2 millimeter. I just did a misclick. Nice. I took it a moment. No! I want to delete that yet, dummy. No! Wow, keycad. Seriously. In theory, then, we should be able to go for like a 0.5 millimeter trace out from here. Okay, not that big. And into a via. This, oh, no, that's not. Why? It's 4 squares. Yeah. In the case of this is just basically trying to make sure I've got the design of this right. That is routable, which it is, so that's good. That's looking very, very promising. This is the switching node. We need an inductor in here still, which we don't have, but that's fine. Also, the layout for this thing's really tetchy, as you know, so I was planning to just lay it out for you, so you just have to throw in parts. Good point. But this has got similar maths for the inductor. So I'm just going to set this the same inductor, even though we haven't run the maths. Because we easily passed that one. I put that in... Oh, right, I put that in for this one. No, not that one. There we go. MFR. Kind of. I'm doing one for each half of the RAM. And each FPGA's core rails, but then shared for quite a bit of the other stuff, because we'll actually still have a channel free for each for a couple more voltage rails, and then the Vout 5 will be the gigabit transceivers for one FPGA each. Because, like, the 1.8 volt stuff, for example, yes, we do. The 1.8 volt stuff, for example, we don't need, that higher current by comparison to, like, the core voltages. Because it's just for I/O. And whatever the, USB chip needs, right? So I can get away with only using a comp 4 here, channel 4 here for that. So RAM is taken care of with this, 1.8 volt core is taken care of with this, and we can kind of run some other stuff off of those that they're actually quite overbuilt. 1.0 volt core is taken care of. And then we get to choose what other rails we put on channel 4 here. So then we only have a little bit more. Yeah, okay. But, like, everything I've done here, I get to just duplicate over here when we're done, because those are the V-core for the FPGA and the RAM voltage taken care of. 1.8 volt down here on channel 3. So that is... these all here powered. Your transceivers powered. Obviously the core voltage for each of these two powered. What else? There was a couple more things as well. So it does cover a decent amount of stuff at least. And I'm thinking the inductor will go about here. So it taps onto this switched line, and then also can be easily tapped over to here for power monitoring. I didn't yet do a footprint for the inductor. Which we should do so we can finish these two channels. Datasheet. And this will be the last part I do before I wrap up my stream to eat, because I'm getting very hungry. What library would you like this in? Would you like this in the project library? Create a footprint. None of those. What? Why did that go to the footprint wizard? Oh, I see. They've renamed some stuff. So this is the... I don't actually know how they do this normally. I guess that will do. Oh, balls. That one. There we go. New footprint. There we go. Now it wrote it. What grid am I on? Ah. We want this to be... Yeah, no, that actually makes a lot of sense. That'll be fine. It's not what I wanted to do. Box. We want a box. .2. So this is 5.2 divided by 2. 5.2 divided by 2. It looks like they're basically square, but then, yeah, there's the 5.2 again. Okay. And then we do 1.1 by 2 millimeter pad. Pad size, or pad shape, rounded rectangle. We'll fix that in a moment. 1.1 by 2. 2.5%. There we go. But now, here's the thing. That's just the size of this itself. That doesn't give any space for soldering. And they are asking for some fairly seriously huge pads. Fair enough. Well, thank you for joining. Thanks for coming and playing along. Gen Hex. So the back side of this is at 1.1. So if I take the X, oh right, yes, of course, minus this is going to be a whole thing. So it's 1.1 plus our 0.25 that we've added onto the pads. From the total pad width. I did that the wrong way around. Whoopsie. Just add. There we go. Oh, that one's subtract. Whoops. There we go. So if I now draw on this, we'll go on to the fab layer for this. Let's draw a rectangle. This is 5.2 divided by 2 minus 11. Sorry, 1.1. And then, how wide is that? Oh, 5.7 for the front side. It's 2 millimeters centered around Y. Almost like I haven't made this big enough, actually. Because it's not the right size. That's why the numbers weren't working out properly. We'll grab that, we'll apply it to this pad, and make this 7.5. Draw another rectangle. Not sure if I actually managed to draw it. There we go. That still feels like these pads are perhaps a bit too small. 3mm? Oh, that's the wrong dimension. Ah! I was adjusting the wrong dimension, that's why. That looks okay, I think. That'll certainly work, so... Set the footprint. And let's see how horribly huge these are. Oh, I left the details floating way off to one side. Oops. Oh, hang on. Why are those... Seriously? Oh, that's annoying. Oh, because I didn't set it as SMD, I set it as... Oh my god, that's so annoying. Pad number 1. Pad number 2. Let's just update these again. Update all footprints with that. Go. There we go. So this would go right in. There, basically. I do need to adjust the fact I didn't put a keep out on. Actually, do we want to keep out here? Because we know that that clears, and the keep out's going to have to be really funky. I should do a keep out. So 1, 2, 1, 2, 1, 2. Two. There's a good keep out. Excellent. That actually perfectly fits, so that's good. And not too enormous. Nix that one to... Well, actually, no, we've got enough space around there to have Q3 show, so that's fine. I'm gonna try and make this a nice mirror image because the pinouts are so close. Ah, that's already in the right spot. Excellent. Oh, I should also name the switching node. Close that now. There we go. So let us label this +1B35K7LSW. That's better. Is that one? Yeah, that's the other resistor that has to go here. Which is going to make everything budge over very slightly. Because, of course it is. In actual fact, I should move. Fine, I'm moving both of them at the same time, apparently. Whoa, too big. Cute. Let's see, what else do we need to do to make this work? Let me budge that up. Actually no, I can get that out still. That's all that matters there. But I do need to budge this up a little bit more. Why did that just reset where my routing was going? It's not annoying in the slightest. I need to unbind that. That was, I accidentally hit Z and things happen when I do that are bad. There we go. Okay. So yeah, that proves that this layout can work. Let's pull the last of the parts down in, because there are a couple more to go. This chunky one, let's route this. Nice. This is a certain level of satisfaction about just how well designed this chip is. I can't say that the board's well designed on my part. Like, my routing's actually kind of horrible. Aki's routing's good. And I know she's gonna nyar at me for that one, but it is. I'm doing hack job routing right here. Actually, okay, that works. This is a very similar bit of routing here. Oops. There we go. Okay, and then we can do the little rooty acrossy bit here. If KiCad will be nice. There we go. And that's the feedback network. That's looking good. I'm okay with that. We haven't yet put the output caps on, but it's kind of a bit what it is. It gives us an idea though. These power supplies are actually going to be pretty small, so that's good. I mean, that's the biggest part of those supplies done, which is kind of mental, really. What is the 3D view of this? Let's see if this is gonna work. Kind of. Where have all my passives gone? What? Those passives loaded. But these ones didn't? What? Huh. Sorry. I try to please. I aim to please. Yeah, okay. Looks like we can handle 6 amps here, so that's good. And yeah, that just leaves this other half of this one to go, and then we mirror that onto this one, and that's quite a lot of supplies taken care of. So with that, I have been going for just about 4 hours. I need to go and sort myself something to eat, because thank you all for watching, and I will see you next weekend for my normal slot, where I will be working on MX Keyboard, I think is the plan, or SPI Flash Programmer. As I was saying last night, I've got 2 projects I could work on next weekend, and it really depends a little bit on what I get done during this week. So, one of those 2. Until then, take care. Bye for now.